we have done up to number 4, third part. Now in first part of question number 5, question is cos theta divided by 1 minus sin theta, and we have to prove that this is equals to 1 plus sin theta by cos theta. So let me start from the left hand side. In the left hand side, it is given cos theta divided by 1 minus sin theta. Now if you see the right hand side, in the numerator it is 1 plus sin theta. Since in the numerator it is 1 plus sin theta, so we are going to multiply both numerator and denominator by 1 plus sin theta. In the next step we can write cos theta by 1 minus sin theta. This one will be multiplied by 1 plus sin theta. Since in the denominator we have written 1 plus sin, in the numerator also it will be 1 plus sin theta. Clear? If we multiply denominator by 1 plus sin, then numerator also must be multiplied by 1 plus sin. Now cos theta 1 plus sin theta, then here we can use the formula a plus b into a minus b. It will be a square minus b square, so 1 square minus sin square theta. Now it will be cos theta 1 plus sin theta. Now we know sin square theta plus cos square theta equals to 1. Since sin square plus cos square is 1, so cos square theta will be 1 minus sin square, so 1 minus sin square theta. So instead of 1 minus sin square, because 1 square will be 1, 1 minus sin square will be cos square theta. One of the cos will cancel, so we can write here cos theta 1 plus sin theta divided by, you can write here cos theta into cos theta, 1 cos theta cancels, so we are going to get 1 plus sin theta divided by cos theta, which is the required right hand side. So just write RHS. Clear? In most of the sums, whenever sums are of this type, cos theta by 1 minus sin theta, or suppose it is 1 plus sin, then generally we multiply by its opposite sign. Since here it is minus, we have to multiply by plus. If it is plus, then you multiply by minus. In second part of question number 5, this sum is quite similar to the previous one. Here question is cos theta divided by 1 plus sin theta, and we have to show this is equals to 1 minus sin theta by cos theta. So just see, in the previous case it was minus, so we multiplied by plus. Here it is plus, so we are multiplying both numerator and denominator by 1 minus sin theta. Fine. If it is plus, you have to multiply by minus. If it is minus, you multiply by plus. Now cos theta 1 minus sin theta, here a plus b, a minus b, a square minus b square. Now we know sin square plus cos square is 1, so cos square will be 1 minus sin square. So instead of 1 minus sin square, we can write cos square, and numerator will remain as it is. Now here cos theta, here it is cos square. That means cos theta into cos theta. This cos theta can be cancelled. So we got 1 minus sin theta by cos theta, and this is the required right hand side. So we got the RHS. Third part of 5, question is 1 by 1 plus sin theta plus 1 by 1 minus sin theta, and we have to show this is equal to 2 sec square theta. In the left hand side it is 1 by 1 plus sin plus 1 by 1 minus sin. Now if you take the LCM of denominators, it will be 1 plus sin theta into 1 minus sin theta. 1 plus sin into 1 minus sin. Now this LCM divided by this part, I am going to get 1 minus sin. This LCM divided by 1 plus sin, it will be 1 minus sin theta, plus this LCM divided by 1 minus sin, it will give 1 plus sin. Here you write 1 plus sin theta. This is minus, this is plus, so these two can be cancelled. So we got 2 by 1 plus sin, 1 minus sin, a plus b into a minus b. It will be a square minus b square theta. Since we know sin square plus cos square, sin square theta plus cos square theta, this is equals to 1. So cos square theta will be 1 minus sine square theta. Just we are transferring this sine square in the other side. Cos square theta will be 1 minus sine square. So 2 divided by 1 minus sine square. 1 minus sine square is cos square. So it will be cos square. Now 2. This cos square is in the denominator. If I transfer it, it will become sec square, because we know 1 by cos theta equals to sec theta. So 1 by cos square theta will be sec square theta, which is the required right hand side. So right here RHS. First part of question number 6. Question is cosec theta plus sin theta into cosec theta minus sin theta, and we have to show this is equal to cos square theta plus cos square theta. Now you start from the left hand side. Cosec theta plus sin theta, cosec theta minus sin theta, we can apply the formula a plus b into a minus b. It will be a square minus b square theta. Okay, a plus b, a minus b, a square minus b square. Now you see the right hand side. In the right hand side it is given cot and cos, but here we got cosec and sine. So here we know the relation cosec square theta minus cot square theta equals to 1. So cosec square theta will be 1 plus cot square theta. This relation is known to you. Cosec square theta minus cot square theta is 1. So cosec square theta will be 1 plus cot square. And for this sine, because in this part, in the right hand side it is cos theta. So we are going to use sine square theta plus cos square theta. This is equals to 1. That means sine square theta will be 1 minus cos square theta. Clear? So now instead of cosec square theta, I am going to write 1 plus cot square theta minus sine square theta. Sine square theta will be 1 minus cos square theta. Since in the right hand side it is given in terms of cot and cos, so we have to change this way. Now it will be 1 plus cot square theta minus 1 minus plus cos square theta. This plus 1 and minus 1 can be cancelled. So it will be cot square theta plus cos square theta, which is the required right hand side. In second part of question number 6, question is tan square theta minus sin square theta, and you have to show it is tan square theta sin square theta. In this side, in the left hand side it is tan theta and sin theta. In the right hand side also tan theta sin theta. Now what to do? We will convert this tan in the form of sin and cos. Since we cannot take anything common, we cannot apply any formula directly. So tan theta we are going to represent in terms of sin and cos. So in the left hand side we can write tan square theta minus sin square theta. It can be written as sin square theta by cos square theta minus sin square theta. Since tan theta is sin by cos. Now from this part we can take sin square theta common. If I take sin square theta common, then we are left with 1 by cos square theta minus 1. Clear? From these two terms, this is the first term, this is the second term, we can take sin square theta common. Then here we are left with 1 by cos square theta minus, since sin square theta I have taken common, 1 is left. Now we can write sin square theta. Here LCM, here actually it is 1 by 1. LCM of 1 and cos square theta is cos square theta. Cos square theta divided by cos square theta, it will be 1 minus cos square theta by 1 is cos square theta, so it will be 1 minus cos square theta. LCM of cos square theta and 1 is cos square theta. This cos square theta divided by cos square theta is 1. 1 into 1, 1 minus cos square theta divided by 1 is cos square theta into 1 is cos square theta. So this can be written as sin square theta into 1 minus cos square. We know sin square plus cos square is 1. So 1 minus cos square will be sin square. So here you write sin square theta by, here it is cos square theta. Now this sine square will remain as it is. Instead of this sine by cos, we can write tan. So since it is sine square theta by cos square theta, it will be tan square theta. In the right hand side also it is the same term, tan square theta into sine square theta, which is equals to tan square theta into sine square theta. It's the same thing, which is the required right hand side. Hence proved. In third part of question number 6, it is given 1 plus tan square theta into 1 minus sine into 1 plus sine, and we have to show this is equals to 1. So here directly we can apply the formula here, a plus b into a minus b. Even 1 plus tan square formula can be applied, because we know sec square minus tan square is 1. So 1 plus tan square will be sec square. So instead of 1 plus tan square, we can write sec square theta, and here a plus b, a minus b, it will be a square minus b square. Here in the bracket you can write since sec square theta minus tan square theta equals to 1. Clear? Since we have used this formula, sec square theta minus tan square theta is 1, in the bracket you mentioned. Now it will be sec square theta 1 minus sine square. 1 minus sine square, we can use this formula. 1 minus sine square will be cos square. So here you can write cos square theta. In the bracket you write since sine square theta plus cos square theta, this is equals to 1. Now sec square theta, sec is the reciprocal of cos, so we can write sec square theta is 1 by cos square theta into cos square theta. These two will cancel, so net result is 1, which is the right hand side. So just write RHS. In first part of question number 7, it is given that cos theta into sine of 90 minus theta plus sine theta into cos of 90 minus theta, and we have to show this is equals to 1. Now if you take the left hand side, cos theta sine of 90 minus theta plus sine theta cos of 90 minus theta. In previous exercise we have done this formula, sine of 90 minus theta. So we can write here cos theta sine of 90 minus theta will be cos theta again, because we know sine of 90 minus theta is cos, plus here it will be sine theta, and cos of 90 minus theta is again sine theta. Now cos theta into cos theta, it will be cos square theta. Sine theta into sine theta, it will give sine square theta. Okay, sine theta into sine theta is sine square theta, and if we use the first relation, sine square theta plus cos square theta, it will be 1, which is the required right hand side. Hence proof. In second part of question number 7, question is cos square 90 minus theta plus cos square plus sec square 90 minus theta minus cos square, and we have to show that these two sides are equal. So if you start from the left hand side, it is cos square 90 degree minus theta plus cos square theta. Now cos of 90 minus theta is sine theta, so this will be sine square theta plus cos square theta, and we know square theta plus cos square theta is 1, so it will be 1. We know cos of 90 minus theta is sine theta. Since square is there, it will be sine square theta plus cos square theta, and this will be 1. Again from the right hand side, in the right hand side it will be sec square 90 degree minus theta minus cos square theta. Now sec of 90 minus theta, we know sec of 90 minus theta is cosec theta, so it will be cosec square theta. Clear? Sec of 90 minus theta is cosec theta, so sec square 90 minus theta will be cosec square theta minus cos square theta. This is also equals to 1. So in both the cases we got 1, therefore LHS equals to RHS. In first part of question number 8, question is sin theta minus cosec theta into cos theta minus sec theta, and we have to show this is equal to 1 by tan theta plus cot theta. Now can we apply any formula directly? No, because we cannot use a plus b, a minus b, or it is not given in terms of squares, so we cannot use these relations. Since we cannot use any identity, or we cannot use a plus b, a minus b, so it is better to convert all the terms wherever possible in terms of sine and cos. Now this sine, it will remain as it is. This cosec theta can be written as 1 by sine theta, and this cos theta also it will remain unchanged. and this sec theta will be 1 by cos theta. Since no relation, no identity can be applied, okay, since no identity can be applied directly, so we are converting this cosec theta in terms of sine and this sec theta in terms of cos. Now LCM here will be sine theta, because here actually it is sine theta by 1. 1 into sine theta is sine theta, so sine theta is the LCM. LCM divided by 1 is sine theta, sine into sine, sine square theta minus sine theta by sine theta is 1. 1 into 1, 1. Here LCM will be cos theta. Cos theta, here also it is 1. So cos theta divided by 1 is cos theta. Cos into cos, it will be cos square theta minus cos theta divided by cos theta is 1. It will be 1. No, sine square theta plus cos square theta equals to 1. We want sine square. So sine square theta will be 1 minus cos square theta. So instead of this sine square theta, we can write 1 minus cos square theta minus 1 by sine theta. And here cos square theta minus 1. So cos square theta minus 1, from here we can write cos square theta equals to 1 minus sine square theta. Now instead of cos square theta we can write 1 minus sine square theta minus 1 by cos theta. Clear? Instead of this sine square theta we have written 1 minus cos square. Instead of this cos square we have written 1 minus sine square. Now this plus 1 minus 1 cancels, plus 1 minus 1 cancels. So in the numerator minus minus plus sine square theta cos square theta divided by sine theta into cos theta. Minus into minus plus sine square theta cos square theta, and the denominator contains sine theta into cos theta. Since here it is sine square, here it is sine, so if I cancel, then it will be sine theta. If I cancel one cos, it will be cos theta. So from the left hand side we got sine theta cos theta. Now in the right hand side it is given that 1 by tan theta. In the right hand side it will be 1 by tan theta plus cot theta, tan theta plus cot theta. Just like the left hand side, here also tan theta and cot theta we are going to convert in the form of sine and cos. So it will be 1 by sine theta by cos theta, and cot theta is cos theta by sine theta. Now LCM of cos and sine, it will be sine theta into cos theta. LCM of these two will be sine theta into cos theta. This LCM divided by cos theta is sine theta. Sine into sine, sine square theta, plus this LCM divided by sine theta is cos theta. Cos into cos, cos square theta. So it will be 1 divided by, we know sine square plus cos square is 1. So it will be 1 by sine theta cos theta. Since 1 divided by this, so it will become sine theta into cos theta. So in the left hand side also we got sine theta cos theta, right hand side also we got sine theta cos theta. Therefore LHS equals to RHS. Hence proved. Second part of question number 8. Question is sine square theta plus cos to the power 4 equal to cos square theta plus sine to the power 4. Just see here, problem is that here you cannot take anything common, and already it is given in terms of sine and cos. So we are starting from the left hand side. This is sine square theta and this part is cos to the power 4. This cos to the power 4 I can write in terms of cos square theta whole square. 2 to the 4 powers are always multiplied. So instead of 4, I can write cos square to the power 2. This can be written as sine square theta plus, now cos square theta is 1 minus sine square. So instead of cos square theta, we can write 1 minus sine square theta whole square. Now this can be written as sine square theta plus a minus b whole square. A minus b whole square formula is a square minus twice ab plus b square. Okay, a minus b whole square is a square minus twice ab plus b square. So this will be sine square theta plus 1 minus 2 sine square theta plus sine to the power 4 theta. So we need sine to the power 4 theta. We got sine to the power 4. So in the next line it will be 1 sine square theta minus 2 sine square theta. Sine square theta minus 2 sine square theta. It will be minus sine square theta. This plus 1 I have written here. Sine square theta minus 2 sine square theta will be minus sine square theta plus sine to the power 4 theta. This step is little bit difficult. Sine square theta plus 1 minus 2 sine square theta plus sine to the power 4 theta. In the right hand side I need sine to the power 4 theta, so I am not disturbing it. Now sine square theta minus 2 sine square theta, it will be minus sine square theta, and this 1 I have written here. So from this line we got 1, from this 2 minus sine square theta plus sine to the power 4 theta. Now 1 minus sine square, we know sine square plus cos square is 1. So 1 minus sine square will be cos square. So from this 2 we got cos square theta plus sine to the power 4 theta. And if you see the right hand side, this is the expression. So this is the required right hand side. The third part of question number 8, you can do it yourself because it is similar to the second part. So now let me show number 9. Here question is sec to the power 4 theta minus 1 minus sine to the power 4 theta minus 2 tan square theta equals to 1. Now since here powers are given 4 power, so we are going to convert in terms of square. Okay? In the left hand side it is given sec to the power 4 theta. This can be written as 1 by cos. This sine to the power 4, it can be written as sine square square. So this sec to the power 4, we can write 1 by cos to the power 4 theta. 1 minus sine to the power 4 can be written as 1 minus sine square theta whole square. And here it will be minus 2 tan square theta. The next step we can write 1 by, since it is cos to the power 4 theta, it can be written as cos square theta into cos square theta. Here a square minus b square. A square, 1 can be considered as 1 square. So a square minus b square, it will be a plus b into a minus b minus 2 tan square theta. Now in the next step we can write 1 into this, it will remain same, 1 plus sine square theta. Now 1 minus sine square theta, we know the relation sine square theta plus cos square theta is 1. So 1 minus sine square, it will be cos square. So instead of 1 minus sine square we can write cos square theta, and in the denominator it will remain as it is. It will be cos square theta into cos square theta. Now minus 2 tan square theta can be written as sine square theta divided by cos square theta. Okay, minus 2, instead of tan square theta it will be sine square theta by cos square theta. This cos square theta and this cos square theta can be cancelled. Now we are going to get LCM will be cos square theta. Cos square theta divided by cos square theta is 1. So it will be 1 plus sine square theta minus cos square theta divided by cos square theta will be 1. So 1 into this, it will be 2 sine square theta. Now 1 sine square theta minus 2 sine square theta, it will be minus sine square theta divided by cos square theta. 1 plus sine square theta minus 2 sine square theta, so it will be minus sine square theta divided by cos square theta. 1 minus sine square, it will be cos square theta by cos square theta, so it will be 1. In the right hand side also it is 1, so we got the required right hand side. Hence proved.